The universe is vast, filled with more stars than grains of sand on Earth. For centuries, we've looked up and wondered, are we alone? This question drives us to explore, to build great machines, and to peer into the deepest corners of space. The search for extraterrestrial life is not just science, it's a fundamental part of the human journey. Now we have a new tool, the James Webb Space Telescope, or JWST. Orbiting 1,000,000 miles from Earth, JWST is our most powerful instrument for exploring the cosmos. Its mission to look back in time to the first galaxies, study the birth of stars, and, most thrillingly, hunt for signs of life on planets orbiting other stars. This is not science fiction. This is real. For the first time, we can analyze the atmospheres of distant worlds, searching for the chemical fingerprints of life. JWST is a cosmic detective, gathering light that's traveled trillions of miles to reveal the secrets of alien skies. The signals are faint, the distance is immense, but the potential reward is the greatest discovery of all time. Our ancestors looked at the same stars and told stories. We see suns circled by planets, some possibly like Earth. The JWST is our modern ship of the imagination, sailing across the cosmic sea. It carries the hopes and dreams of everyone who's ever looked up at the night sky and wondered. The great cosmic hunt has officially begun, and we are all part of it. We are actively searching for our cosmic neighbors. This marks a turning point in human history. The search for life beyond Earth connects us to our past and propels us into the future. The journey has begun. What makes the James Webb Space Telescope so special? Its primary mirror, over 21 feet wide and coated in gold, captures invisible infrared light. Infrared lets Webb see through cosmic dust, revealing hidden stars and the atmospheres of distant planets. Unlike Hubble, Webb orbits far from Earth at a stable point called L2, kept cold by a giant sunshield. This sensitivity makes JWST perfect for hunting signs of life. When a planet passes in front of its star, Webb captures the starlight that filters through the planet's atmosphere. Its instruments can detect subtle chemical changes in that light, clues to what an alien sky is made of. JWST is more than a telescope. It's a time machine and a chemical lab in space. It can look back over 13 billion years and sniff the air of planets light years away. For decades, this was only a dream. Now, it's reality. Through JWST's new window, we may finally find the answers we've been searching for. Yesterday, NASA announced a bold new mission for JWST, a dedicated program to scan exoplanet atmospheres for signs of life. This marks the official start of the telescope's alien hunt mode. Years of planning and early successes, like detecting water vapor and methane, prove the technology works. Now, JWST will focus on a select list of promising planets in the habitable zone, where liquid water could exist. One prime target is K218b, a super-Earth 120 light-years away, already showing intriguing chemical signs. Hundreds of hours will be devoted to building detailed pictures of these worlds' atmospheres. The announcement has electrified scientists and the public alike. For the first time, we're not just asking, are we alone? We're actively searching for the answer. The data collected could change our view of the universe forever. We stand on the brink of a new era of discovery. The universe has secrets to share, and JWST is ready to listen. The search is no longer a dream. It's happening now. The hunt is on. How does JWST sniff the air of a planet light years away? The answer: transit spectroscopy. When a planet passes in front of its star, some starlight filters through its atmosphere. Different gases absorb specific colors of light, leaving a unique chemical fingerprint. JWST spreads this light into a spectrum, revealing dark absorption lines, each one a clue to the planet's composition. Water vapor, methane, oxygen, carbon dioxide all have their own barcodes. By reading these, astronomers can tell exactly what's in an alien sky. This method is so sensitive, it lets us analyze worlds we'll never visit. We're searching for biosignatures, chemical clues that point to life. For example, finding both oxygen and methane together would be a thrilling sign. On Earth, these gases are constantly replenished by life. If we find them elsewhere, it could mean something is alive out there. JWST gives us the tools to find out. Spectroscopy is the science of light, the key to unlocking distant worlds. Every element and molecule has a unique spectral fingerprint. JWST's advanced instruments like NIRSpec and NIRIS can detect even tiny amounts of gases in exoplanet atmospheres. This tells us not just what's there, but how much, crucial for judging habitability. Water vapor is a great start. Carbon dioxide reveals climate, the real prize biosignatures, gases unlikely to exist without life. By studying the full spectrum, scientists model a planet's atmosphere, temperature, and even weather. We're transforming distant points of light into real detailed worlds. Spectroscopy is turning the unknown into the knowable. One of JWST's most exciting targets is K218b, a super-Earth in the habitable zone, 120 light-years away. Previous telescopes hinted at water vapor, but JWST confirmed it, along with carbon dioxide and methane. These molecules are the building blocks of life on Earth. Finding them together on a single exoplanet is a major step forward. Even more intriguing, a possible signal of dimethyl sulfide or DMS, a molecule produced by life in Earth's oceans. The DMS signal is weak and needs confirmation, but if real, it would be a powerful biosignature. That's why JWST is dedicating so much time to K218b. These discoveries show JWST's incredible power and the careful step-by-step nature of science. Each observation adds a piece to the puzzle. K218b might be a Hycean world, an ocean planet with a hydrogen-rich atmosphere, very different from Earth. The findings don't prove life exists there, but they're deeply encouraging. We're looking in the right places, and the universe may be more interesting than we ever imagined. The search continues, fueled by every new clue. The cosmos is whispering, and we're finally able to listen. A JWST can do more than analyze atmospheres. It can take direct images of exoplanets. This is incredibly hard. Planets are faint, lost in the glare of their stars. Webb uses coronagraphs, tiny masks that block starlight, to reveal the faint glow of orbiting planets. In 2022, JWST captured its first direct image, HIP 65426b, a gas giant many times Jupiter's mass. This was a landmark achievement, proving Webb could image exoplanets directly. Direct imaging lets us study planets that don't transit their stars and measure their brightness, temperature, and orbit. These images provide crucial data, complementing what we learn from spectroscopy. For gas giants, we can study cloud structure and chemistry. As technology improves, we hope to image smaller, rockier worlds, even Earth-like planets. One day, we might see a pale blue dot orbiting a distant sun. That would be a transformative moment for humanity. The future of exoplanet discovery is bright. The hunt for alien life is not easy. JWST faces immense challenges. The signals are faint, the distance is vast, and the data subtle. Even a little noise can obscure the clues we seek. False positives are a real risk. Geology or photochemistry can mimic biosignatures. Scientists must rule out every non-biological explanation before claiming a discovery. We need to understand each planet as a whole system, its star, mass, density, and all atmospheric gases. True confirmation will require multiple lines of evidence, all pointing to life. Detailed models from JWST's data help us distinguish between interesting worlds and truly living ones. Time is another challenge. JWST is just one telescope, and observing time is precious. Thousands of exoplanets await study, but only a few can be targeted. The search will take years, maybe decades, but every step pushes the boundaries of knowledge and technology. The journey itself is a reward. On July 2, 2025, we stand at the dawn of a new age of exploration. JWST is systematically scanning the skies, listening for the chemical whispers of life. We are closer than ever to answering, are we alone? The first evidence may be ambiguous, a strange chemical imbalance debated and tested. Discovery will likely come as a growing consensus, not a single announcement. If we find life, even microbes, it will change our view of the universe forever. If we find nothing, it will make Earth even more precious. Either way, the search is noble, pushing us to build, to collaborate, to ask the biggest questions. JWST is our messenger to the cosmos, and we await its reply. The cosmic question remains, but for the first time, an answer feels within reach. The universe is waiting, and so are we.